Well, hello folks. I've had a few requests from various sources on some of the CAD drawing I do. One of the most common ones is how do I draw a chimney. So it's not the most straightforward thing to do, but today we're going to go through the method I use for one of my locos. Not necessarily the best method. Some people have their own preferences. Different methods will work better with different CAD software and so on. So we're just going to try this one out. Apologies for the audio quality, I'm just using a laptop mic and it's 30 plus degrees in here today, so the fan is probably going a bit crazy. So we've got our blank slate. We'll start by starting a new sketch, and we're going to be using the revolve tool for this. So what I want to do here is draw about half of the chimney in profile. So I've got my drawings in front of me. If you hear a lot of rustling of paper, that's what that is. I'm just going to roughly draw out the outline of the chimney. So the one I'm making today is fairly short, looks a bit like this, and I'm just taking measurements directly off the drawing I've got in front of me. I'm not drawing the base or flange that joins it to the saddle tank at the moment, so this loco is a saddle tank type. The reason for that will become clear shortly, hopefully. So if your drawing goes a bit funky like this, you can just grab some of the individual points and put it back to roughly how it's supposed to look. Didn't want to pick that one. So all of this is just one rough drawing and then sticking dimensions on it. It's fairly straightforward. And I'm trying to keep this video all in real time, not just to save myself an editing job, but also so it's actually clear how long this takes as a process. I don't find it's a particularly arduous one. Yeah, the idea is not to sort of fake a really quick version of it or try and pretend that it takes me days and days to do what is a fairly simple job, really. Should be a little bit longer than that. Some of these dimensions being adjusted on the fly, as you can't always trust the drawings, so I'm looking at photos as well to make sure it kind of matches the profile I'm going for. Okay, I reckon that's about right. So let's get our revolve on. So it's defaulted to selecting this profile because it's the only one that's in there at the moment. I'm going to put that in my axis. And I forgot to do something, didn't I? So it wasn't a good start. We want to set this to our minimum wall thickness that we want, which in this case is going to be 0.75 millimeters. That's going to be the minimum thickness, which I think we'll just about be able to get away with. Okay, so now we select our revolve. 360 degrees, new body because there's nothing else in here. I'm using Fusion 360. In case you hadn't worked that out already, but a lot of CAD software is very, very similar, so you shouldn't have too many issues. Right, so now we're going to stick a couple of rounds on here. At 0.25 millimeters is half of that distance because I made that 0.5 deep. So that's our first one. You can combine multiple rounds by using this thing in one go, but I prefer to keep them separate just because it's easier to find what you're looking for afterwards. And the other one we want is this one. Something like that is what we're looking for. Right, so that's that bit done. Next thing to do is the flange that connects this to the base. So I'm just going to draw a couple of vertical lines at random points, make them equal, and dimension to the thickness of the flange that I want, which I'm going to measure at about 0.3 millimeters, which is not large. I'm going to create a couple of arcs between those 2 points, again just at random dimensions for now. This is one of the things I tend to see a lot of people doing that are fairly new to CAD, is you'll try and get everything in the right place to start off with, and that really just slows you down in my opinion. You can get used to putting things in at fairly random locations, make it bigger than you need to. I then find it easier to do that and then dimension it afterwards, which also gives you the opportunity to go back and tweak things a lot more easily as well. So I want to tangent that onto there, and I want to dimension this with the radius of my saddle tank in this case, although you'd swap that for the radius of your smoke box otherwise. So that should be 15.75 millimeters because I measured that earlier. And you can see our centre point is sat down here, and we'll sort of move around in ways that we don't want at the moment. So the next thing I'm going to do is add a construction line vertically downwards, like that, which has gone black, so that means it's fully dimensioned. And then I'm just going to move that centre point onto here. So that should now be bang in the middle. So this here I'm going to make concentric of this, which should put that in the right place, and that's moved everything into the centre. So the ideal is to use as few dimensions as possible and use as many of these constraint tools up here as we can. The next thing I need to do is dictate the overall width of this particular flange, which is, check my drawing, 7.75 millimeters. And again, all this constraining we're doing is just keeping it central, so we don't have to put any extra dimensions that we don't need on them. Next thing to check is that this flange comes inside here, so we don't have it coming under here and having a gap. If you have a really small radius smoke box, that can sometimes happen, so you just need to watch out for that. So I reckon that's about done. We want to extrude that sketch in both directions. So I'm going to pick two sides, and I'm going to pick symmetric. I want a whole length measurement of 7.75 millimeters, which is that measurement we did across. It should be the same. I want to join those on, and then I want to create a cut in here of another circle, which should, again, tangent on to here. Again, no dimensions. That means if I change that 7.75 millimeters width later on, this will also change to match it, which is what I want. Although I forgot to add the extra circle for my cut in here, which I'm just going to make much bigger than I need to. Then I'm going to extrude that in two sides, and again this doesn't need to be super precise, it just needs to be shorter than this point here so I don't cut that off by accident. and the other side it can just go all the way. That's the wrong side. There's this side 2 meters, that should be all. Okay, it doesn't like that. So I'm just going to put 5mm in for that side and a generic distance of 1mm in for that side. We want it to be a cut. So there we go. That's pretty much done. We just need to put a nice big round in here to match the photos that I have of this locomotive. No, not that much. That looks about right to me. It's a very short chimney, this one, because it's a big old cellar tank, so that will do. Some locomotives will also have a round on this sort of lip here. This particular one doesn't. And some locomotives will also have a set of rivets around the edge, but that's much easier to add later on. So I think we'll call that job done. Thanks for watching.